Hi again, this time we're going to talk about other ways to think about and use integration. So it's pretty much the same as what we did last lesson, but I'm just going to show you with some graphs and I'm going to do a couple of examples, and we're also going to learn to integrate with respect to y today for the first time. So let's look at this little graph. If we're integrating between 6 and 0 of this quadratic function, what we're finding is this area here, the one I just colored in. So it is the curved space between the x-axis and the graph. So the area bound by the graph and the x-axis is how we speak about that. Now, hopefully you can tell that this is just a normal quadratic, and if we wanted to solve it, we would solve it like we always do. So we've got x minus 6, so x is 0 and 6, which we can see are our x-intercepts here. And that is what we're being asked to find. I mean, they could ask us to find a bit in the middle. We don't have to find the whole thing, but that is what this question has asked us to do. So let me just get rid of what I just drew. Okay, so I'm just going to erase that because it's in the way, but you get the point. This is just a quadratic graph, and we're now going to find that area. So the first thing I'm going to do is integrate this function. So the integral is going to be x to the power of 3. So add a power, divide by the new power, and then 6x add a power squared, divide by the new power. So that gives me 1/3 x cubed minus 3x squared plus c. But as we learnt from the last video, we don't actually need to use the plus c because it cancels out anyway when we're doing definite integration. So if I just plug in 6 and 0, so I'm going to get 1/3 times 6 cubed minus 3 times 6 squared, and I'm going to subtract 1/3 of 0 cubed minus 3 times 0 squared. Now, if you use your brain, you're going to recognize that all of that cancels out to 0, right? Anything times 0 is 0. So none of that actually has any bearing on the question at all. So I'm going to ignore it. And I'm just going to type this into my calculator, which gets me negative 36. So negative 36 and its units squared, right? Because we're talking about the area of a curved space. Okay, let's do one that's a little bit different. Let me just save that. So we've got two other versions of this that we can do. So one of them, so let's, for example, say that I have something I'm asked to integrate. Let's do a cubic. So I'm going to integrate between 2 and 0, and I'm going to do a cubic function. So x minus 2 x minus 6 with respect to x. Now, the very helpful thing about this is we know how to solve this. The values of x are going to be 0, 2, and 6. So if I was to draw this, I would know that my x-intercepts are 0. Let's say that that's 2, and let's say that that's 6. And this is a positive cubic, so we know that it's shaped like this. So I'm going to draw that. So I'm going to draw that goes like that and then goes like that. So this is my cubic graph, and you don't have to draw them. I'm just trying to make a point about what they look like. So we're going to find the area bound by the graph and the curved space. So what I'm going to do is I'm going to find this bit here, and I'm also going to find this bit here. Now, the problem with this is it's a little trickier than some of the other ones, because what I need to do is think about the fact that when I work out the areas, one of them is going to be positive and one's going to be negative. So I can't just put them together. Otherwise, they'll start to cancel each other out because I've got one above the x-axis here and I've got one below the x-axis here. So what I'm actually going to do is I'm going to have to work them out slightly separately. So if I wanted to know that, sorry, I shouldn't have written the 2 and the 0 up here before, because actually what I want to know is 6 and 0. Sorry, I want to know 6 and 0, but I have to do it separately. So what I need to do is integrate between 2 and 0, and then I also need to integrate between 2 and 6. If this is 0, 2, and 6, I've got two separate areas I need to work out. So let's do the 2 and the 0 first, and then we're going to add it to the integral between 2 and 6. So the first thing I need to do is open all of this up. So I'm going to have x cubed minus 8x squared plus 12x. So if you open all of that up, that is your expanded version of the original. So now I'm going to integrate with respect to x between 2 and 0. So again, add a power, divide by the new power. Minus 8x cubed, add a power, divide by the new power. 12x squared, divide by the new power. So then this is going to be 1/4 x to the power of 4 minus 8/3 x cubed plus 6x squared. And I'm going to have to put 2 and 0 in that. Obviously, you'll know that if I put 0 into this, everything's going to be 0. So who cares about that? I'm just going to do the 2. So it's going to be 1/4 times 2 to the power of 4 minus 8/3 2 cubed plus 6 times 2 squared. And I've run out of space. And if I type all of that into a calculator, slash do it in my head if I can be bothered, I am going to get 6 2/3. So the area of this first space here is 6 2/3. So what I need to do now is the second space between 2 and 6. So let's do that. I'm going to do it over the other side. So I'm going to integrate between 6 and 2. So I don't need to reintegrate. I've already done that. I'm just going to skip straight to this step here and put in 6 and 2 instead. So I have 1/4, let me put some big brackets in here, 1/4 times 6 to the power of 4 minus 8/3. Let's move over because we do not have enough space. Okay, 8/3 times 6 cubed plus 6 times 6 squared. And I'm going to subtract all of that again. 1/4 2 to the power of 4 minus 8/3 2 cubed plus 6 times 2 squared. And again, if you type all of that into your calculator, this first bit will be negative 36, and the second bit will be 6 2/3. Now, really, I probably didn't need to bother writing out the second bit because isn't that exactly what I did before? I put 2 in, so I should have known that the answer was going to be 6 2/3. So you really don't need to do this second bit, but I was just trying to write it out to be helpful so you can see it all. So that gives you negative 42 2/3. And again, it's units. That is not what you write at all. Units squared. That is the area of the red bit. And then we've got over here the area of the green bit. So in total, what we need to do is add these two things together. Now, I need you to use your brain a little bit and think about the fact that this is negative. The red bit is negative isn't helpful because you can't have negative area. So it's only negative because it's below the x-axis, but the area is still a positive number. So I really have 6 2/3. That did not look like a 3 plus 42 2/3. All right, so I'm going to add them together because they are both positive areas. It's just that, and this is kind of why I said at the start, you have to do them separately. You can't just do them together because you'll end up canceling stuff out because of positives and negatives. So altogether, we have 49 1/3 units squared is the total area for both of the shaded bits. All right, we're going to do one more example, and this one we're going to do with respect to y for the first time. So we've not done that before. Okay, so if I have, let's say that I've got a graph, and this is an inverse function. Okay, so remember, if I have like y equals x squared, I'm going to get a positive graph, right? But if I swap it around, remember I can get x equals, like if I, oh, I suppose if I inverse it, right? So if I swap x and y, and then I've got positive and negative square root of x is y, that gives me the positive square root and the negative square root, right? And we get a sideways graph. So sometimes we get things like that, and that means we might need to differentiate with respect to y. Because what we're doing when we're differentiating, when we're doing it with respect to x, right? When we do something like that, we're finding the area bound between the x-axis and the curve. But in this example over here, I would like to find the area bound between the y-axis and the curve. So I need to differentiate with respect to y. So if I'm asked to differentiate, so let's say I'm going to say that x equals y, hang on, sorry. let's write that better, is, oh no, I'm right, 4 minus y. Okay, so this is the equation that I've got over here. So I'm going to differentiate with respect to y. Now they've already rearranged it so that x is my subject, and I can differentiate with respect to y. So I'm going to rewrite this as 4y minus y squared. And you can see that this is a negative quadratic on its side, which is exactly what this looks like. A negative x squared is a negative quadratic, but this is an inverse version. So if I'm asked to differentiate, um, so what am I differentiating between 4 and 0 of 4y minus y squared with respect to y? So it's no different. All I'm doing is using y instead of x, but I do it exactly the same way. So the first thing I do is obviously integrate. Did I say differentiate? I don't know why I said that. I'm integrating, obviously. So what I'm doing is I'm going to, again, add a power, divide by the new power, add a power, divide by the new power. All right, let's zoom out a bit because I'm running out of space already. Okay, so then we end up with 2y squared minus a third y cubed. And now what I need to do is put in my numbers, 4 and 0. Again, you should be able to tell that if I put 0 into this, it's all going to cancel out to 0 because there are no constants, so I don't need to bother with 0. I just need to put in 4. So I'm going to say that 2 times 4 squared minus 1/3 times 4 cubed. And if I type that into a calculator, I get 10 and 2/3 units squared. That is the area bound by the curve and the y-axis this time. Okay, please let me know if you've got any questions, and good luck.